Here's our problem in parallel and series circuit. So we have a given in resistance and we're going to get the R total. So first one is R1 is 24, R2 is 59, which is this, R3 is 55, this, R4 is 98. So first we're going to solve the R1 and R2. This is the formula in how to get R total in parallel. 1 is over to R1 plus 1 is over to R2. So second is we're going to put and second is we're going to distribute the value of R1, which is 24, plus 1 is R2 is 59. So our R total is 0.05861 resistance. Next is we're going to get the R3 and R4. R total R3 equals to 1 over R4 R3 plus 1 over R4. So we're going to distribute the value of R3 and R4. This equals 55 resistance and plus 1, 28 resistance. So our R total in 3 and 4 is 0.2839 resistance. So this is our total in R3 and R4, and total in R1 and R2 is 0.05061. There you go. So the second is we're going to get the R total in series circuits. So in the formula is RT 1, 2, 3 and 4. So this is 1, 2, this is 3, 4. So the formula is R12 plus R34. So we're going to distribute the values of R1 and R34. RT total 1, 2, 3, 4 is equals the R1 and 2 is 0.0506 plus the R34 0.02839. So our R total in 1, 2, 3, 4 is 0.0506 plus 0.02839 is 0.0789. This is our R total in this problem. And lastly, we're going to get the current of this problem. So we have the formula, the triangle method is VIR. So we're going to get the current, which is I. So our formula is I is equals to V or R total. So we're going to distribute the values of V 24, which is 24 volts, and our R total is 0.0789 resistance. So our current is our current is 304 0.183 ampere. This is our current total, 304.183 ampere. This is our second problem, and this is our values in R1, R2, R3. R1 is 24 ohms, and R2 is 59 ohms, and R3 is 55 ohms. So first we're going to solve this parallel equation. So R2, R total 3 and 2 is equals 1 over R2 plus 1 over R3. So distribute our values in R2 and R3. 1 over our R2 is 59 ohms plus our R3 is 55 ohms. So our R total in 2 and 3 is equals to R1 is 1 over 59 plus 1 over 55. So equals 0.0351 ohms. So this is our R total in 2 and 3. Second is we're going to solve the series circuit. So our formula in series circuit is R1, 2 and 3 is equals to R1 plus R2, 3. That's total. So and distribute our value of R1 is 24 ohms plus our R2 and 3 0.0351 ohms. So our R total in 1, 2 and 3 is equals to 24 plus 0.0351 is equals to 24.0351 ohms. So this is our R total in this problem. We're going to get the current of this problem, which is our given in voltage is 60 voltage, and our R total 1, 2 and 3 is 24.0351 ohms. So our formula is I is equals to V over R total. So our V is 60 volts and our R total is 24.0351 ohms. So our current is 60 divided by 24.0351 is 2.496 ampere. This is our total ampere in this problem. So this is our third problem. We're going to solve this first R1 and R2, which is this is a series problem. So our R total 1, 2 R1 plus R2 R total 1, 2. We're going to distribute the values of R1 and R2. R1 is 24 ohms plus R2 is 59 ohms. So our R total in 1 and 2 is equals to 83 ohms. So the second one is we're going to solve the R1, R2, R3. So we have our R1 and 2. This is our total R1, R2, and our R3 is 55. So we're going to solve it into parallel formula. So our R total 1, 2, 3 is equals to 1 is R12 plus 1 in R3. So our R total 1, 2, 3. Our R12 is 83 ohms plus 1 is equals to 55 ohms. So R total 1, 2, 3 is equals to 1 is 83 plus 1, 55. So our total in R3 1, 2, 3 is 0.0351 ohms. There you go. So our R total in 1, 2, 3, this is our R total 1, 2, 3, 0.0302, and we're going to solve the R4 and R1, 2, 3. So R4 is 98. So this is a series problem. So we're going to total 1, 2, 3, 4 is equals to R1, 2, 3 plus R4. So we're going to distribute the values. So our R1, 2, 3, 0.0302 plus our R4 is 98, and our R total 1, 2, 3, 4 is equals to 98.0302 ohms. So this is our R total in this problem. And lastly, we're going to solve the current of this problem. So our voltage is 300 and our R total 1, 2, 3, 4 is 98.0302 ohms. So the formula of this is V is equals to I is equals to V over R total. I is equals to our V is 300 volts voltage, and our R total is 98.0302 ohms. So our current is 398.0302 is equals to 3.060 ampere. This is our total ampere of this problem. Since this is our last problem, so we're going to solve first this R2 and R3. Since this is a parallel circuit, so the formula of parallel circuit is R total 2 and 3 is equals 1 over R2 plus 1 over R3. So we're going to distribute these values. R2 is 59 ohms plus our R3 is 55 ohms. So our R total 2 and 3 is equals to plus 1 55. So the total of 2 and 3 is 0.0351 ohms. And the second is we're going to solve this R1 and R23. Since this is a series, this is the formula of series. 1, 2, 3 R1 plus R23. So we're going to distribute their values. R1 is 24 ohms plus R23 0.0351 ohms. So our R total 1, 2, 3 is 24.0351 ohms. So this is our total ohms on this problem. Lastly, we're going to solve the current of this problem. Since we have the R total 1, 2, 3, 24.0351 ohms. So the voltage is 30 voltage. So that the formula of the current is I is equals to V over R total. I is equals to V is 30 volts and our R total is 24.0351 ohms. So our current is 30 voltage over 24.0351 is equals to 1.248 ampere. So this is our current total of this problem.